Hello, this is AP Calculus AP course with Mrs. Ryu. I'm gonna try to speak English in this online course and hope you guys all get used to it. And we are gonna skip chapter 1.1, but we're gonna start with chapter 1.2. It says finding limits graphically and numerically. So what is a limit? We are going to start with an example. It says find the limit as x approaches 1. Okay, and we have a function right here. It says x cubed minus 1 over x minus 1. And we also have a graph. What's interesting in this graph is we have a hole when x is 1. Why do we have that? It's because the denominator of the function can't be what? 0. That means x shouldn't be 1, right? So we have a hole because we cannot divide by 0, right? All right. The numerator, okay, let's factor this out. Hope that you guys all remember the formula a cubed minus b cubed, which is a minus b, a squared plus ab plus b squared, right? So in this case, a is the x, b is the 1. So we can factor this out to x minus 1, x squared plus x plus 1 squared, which is 1. All right. So we can simply cancel these two out. So x minus 1 is gone. So let me rewrite the function. F of x is x squared plus x plus 1. But we are not done because x is still not 1. Let's find the limit. So limit, this is a notation. LIM, x is getting closer and closer and closer to 1. Okay, so x is getting closer, 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 closer to 1. Okay. Limit of the function means when x is getting closer to 1, what would the y value be? That's what it means. Okay, so let me write this down here. Whereas x is getting closer to 1, what would the y value be? Okay, so in this graph, as we can see, y value is 3. So in this question, there is no function value at x equals 1 because there's a hole. We don't have that, but we still have the limit. Alright, example number 1, it says find the limit of the function x over square root of x plus 1 minus 1 as x approaches 0. So we have to find the limit. X approaches to 0 of the function. Alright, so here's a small tip. It says when you have a square root minus a number, especially in the denominator of the fraction, what you wanna do? You wanna rationalize the function. Okay? So let me rewrite the function. F of x equals x over square root of x plus 1 minus 1. Alright, how are we going to rationalize the denominator? The same square root, same number, but the opposite sign. So here is a minus, here is a plus. Alright, the same top and the bottom so that we are not changing the value. Using the sum and difference formula, so x plus 1 square root of x plus 1 squared, so that's x plus 1, right? 1 times 1 is 1 and the minus. Okay, I'm going to just leave it like this so that probably we can cancel out something. 1 and 1 and x and x. So what we have is x plus 1 in the square root plus 1. Okay, when we canceled out the x, that means x is not 0 because we cannot divide by 0, right? So that's what we have. Let's graph this. I have x-axis and y-axis. Let me change the color. All right. The parent function is the radical function, so y equals square root of x. I have a plus x, so that means I'm going to change the color one more time. I moved to the left 1 unit. Okay. And I have a plus 1 outside the square root. That means go up 1 unit. So here is our function. Okay, find the limit. So as x approaching 0, okay, what's the y value right here? That is 2, right? And we can see that in the function that we kind of simplified as well. If we plug in the number that is very, very close to 0 to the x, then I think it's going to 2. All right. We just figured out the limit in a graphical way. How about the numerical way? So I just use a calculator. Let me plug in the number that is very close to 0. So x is 0.1, then y is this, 2.048808. When x is 0.01, y value is 2.004985. Okay, even closer. So 2 zeros and 1, y is 2.304998. So as you can see, as x is getting closer and closer and closer to 0, y is getting closer and closer to 2. So 2 is the answer. Okay, example number 2, it says find the limit of f of x as x approaches 2. So we have to find the limit x approaching 2 of this function. Okay. All right, look at this graph. It looks like it is a constant function, like f of x is c. That means the graph should look like a horizontal line. Okay. So let's graph this. X-axis or y-axis. F of x is 1. It has the y value of 1 when x is not 2. But when x is 2, it has the value at 0. So this point is a part of the graph. So we see that f of 2, which is the function value, okay, so exactly at 2, the value is 0, right? But how about the limit? Okay, would it be the same answer, like 0? Let's see. X is getting closer and closer and closer, not exactly at 2, but very, very close to 2. So the limit of x at x approaching 2 of the function is 1. So sometimes, not all the time, but sometimes the function value is not equal to limit. Sometimes equal, sometimes not equal. Okay, students, wash your hands and wear a mask. I miss my students. Bye.